This is section 6.5, and we're going to talk about the tangent and cotangent function. So the properties are quite different than sine and cosine. The domain is the set of all real numbers except odd multiples of pi over 2. So we have some asymptotes, and if you see down in this graph, these dotted lines are the asymptotes of our tangent function. The range is all real numbers. That's different. So our domain is restricted some, but our range goes from negative infinity to positive infinity. It's an odd function, and the symmetry indicates that. So the tangent function is periodic, but its period is pi. Its period is pi, not 2 pi. And what we were talking about here, and I just noticed that I didn't finish that sentence, the symmetry is it's symmetrical with respect to the origin. And so that's what odd functions do. So that's one thing to note there. The x-intercepts are negative 2 pi, negative pi, 0 pi, 2 pi, 3 pi, etc. And the y-intercept is 0. That's on your basic one. Okay, and so that's what happens there. Now, for cotan, you can see this goes from left and goes up to right. This goes falling from left to right. So cotan is doing falling instead of rising. And you can tell that the domain and the range are a little bit different. The range is still all real numbers, and the domain is still where we have vertical asymptotes at integer multiples of pi, 0, pi, 2 pi, etc. So very much like the tangent. It's just that it is falling from left to right. Okay. Now also we'll talk just a little bit about cosecant. And cosecant in our picture here is the blue. And it is the inverse of sine. So if you were graphing it by hand, you would graph the sine function, and then you would draw asymptotes at the x-intercepts, and then your cosecant function is this blue part that goes in and just touches at the max of the sine or the min of the sine. So it's these little pieces. So you can see that the domain is restricted. It doesn't live where these asymptotes are. And the range is usually greater than -1 greater than 1 or less than -1 unless you start changing the function itself. So just know that these are the actual pieces of the cosecant, but it's tied to the sine function. And if you were doing secant, it would be tied to the cosine function. We don't have very many questions in this section. Let's see if we can go look at them. So we're just completing the sentence here. The graph of tan is symmetric with respect to and we said it was the origin, and it has vertical asymptotes at odd multiples of pi over 2. That's in the notes, so you should be able to fill those out. The graph of secant is symmetric with respect to the y-axis and has vertical asymptotes at odd multiples of pi over 2. Secant, the easiest way to graph secant is by first sketching the graph of cosine. Remember, cosecant is tied to sine, secant is tied to cosine. For what numbers, x, where x is between -2 pi and 2 pi, does the graph of y equals secant have vertical asymptotes? Well, remember right up here, we said odd multiples of pi over 2. So it says that you're between -2 pi and 2 pi. So we have to list everything between there. That would be -3/2 pi, negative pi over 2, positive pi over 2, 3/2 pi, 3 pi over 2. I'll say it right in a minute. And so those would be the answers for that. They're odd multiples. For what numbers does y equals tan x have vertical asymptotes? You're going to have the same thing. It's odd multiples of pi over 2. So we've got those. Cotan, those are different. We talked about that in the notes. Cotan is going to be multiples of pi. So negative 2 pi, negative pi, 0 pi, 2 pi. That's going to be the vertical asymptotes for that one. So really, this section, we just talked more about language and just making those connections for right now. We'll pick up some more in the next section.